Level 0. Pluto used to be on every classroom poster, printed on mugs, stitched onto t-shirts, memorized by every kid who learned the planets in order. Then, one Tuesday in August 2006, a room full of astronomers in Prague voted on a definition. And just like that, the solar system lost a member. Schoolbooks became wrong overnight. The vote wasn't really about Pluto, it was about a problem that had been building for decades, because astronomers were finding more worlds out there. Worlds with no category. Worlds that were, in several cases, bigger than Pluto itself. And if Pluto was a planet, then all of them had to be too. The International Astronomical Union had a choice: expand the solar system to somewhere between 12 and 50 planets, depending on how generous you wanted to be, or draw a new line. They drew the line. Pluto ended up on the wrong side of it. What they created instead was a new category: dwarf planets. Worlds large enough to pull themselves into a roughly spherical shape under their own gravity, but not large enough to have cleared the neighborhood around their orbit. That last part is what got Pluto. It shares its orbital zone with thousands of objects in the Kuiper Belt. Jupiter clears its neighborhood so thoroughly, it barely has a neighborhood anymore. Since 2006, 5 objects have been officially classified as dwarf planets, but the actual number is almost certainly in the hundreds. We just haven't confirmed them yet because they're small, far away, and the universe is not obligated to make them easy to find. The next one is the closest to home, a world that was called a planet, then an asteroid, then nothing worth discussing for the better part of 2 centuries. It sits alone between Mars and Jupiter. It has been leaking salt water onto its own surface within recorded human history, and almost nobody brings it up when this subject comes up. Level 1. Giuseppe Piazzi wasn't looking for a new world on January 1st, 1801. He was building a star catalog, tracking positions, doing the unglamorous work of astronomy. Then one of his stars moved. Stars don't move like that. He'd found something orbiting the sun between Mars and Jupiter, and for a while the scientific community called it a planet. Then other objects turned up in the same region, then more. The region became known as the asteroid belt. Ceres got reclassified as an asteroid, and it stayed that way for 205 years until the 2006 redefinition bumped it up to dwarf planet. It is the only dwarf planet in the inner solar system and the only one most spacecraft have actually visited up close. At 949 kilometers, 590 miles across, Ceres holds roughly 1/3 of the entire mass of the asteroid belt. Every other rock, pebble, chunk of iron and stone in that region combined adds up to about twice what Ceres weighs on its own. The belt sounds crowded when you hear about it. Ceres is the reason it isn't. In 2015, NASA's Dawn spacecraft arrived in orbit and spotted 2 intensely bright patches on the floor of a crater called Okator, bright enough to show up in raw, unprocessed images. The internet decided it was a city. Researchers had a different answer, and it turned out to be stranger in some ways than a city. Sodium carbonate, a highly reflective salt deposited by briny water pushing up through fractures in the crust and evaporating in the vacuum of space. Ceres has liquid water activity happening beneath its surface right now, and the evidence for it is sitting in plain sight at the bottom of that crater. The bright spots are not ancient. Geologically speaking, they formed within the last few centuries. A world 413 million kilometers, 257 million miles from Earth, has been quietly leaking salt water onto its own surface well within recorded human history. There's also Ahuna Mons, a cryovolcanic dome rising 6.4 kilometers, 4 miles, above the surrounding plains with no obvious geological neighbors. The leading explanation is that older versions of it have been slowly spreading and flattening for millions of years, absorbed back into the landscape. The one visible today is the current version. The old ones are already gone. Ceres has active geology, confirmed subsurface liquid, and a 2-century identity crisis. It was the first dwarf planet ever visited by a spacecraft, and yet it remains one of the least discussed worlds in the solar system. Most people can name Pluto without hesitation. Almost nobody thinks of Ceres, a world with ongoing water activity, a volcanic dome, and a history of being mistaken for 3 different categories of object, and it barely makes the conversation. By the standards of the other worlds on this list, it is the calm, unremarkable one. The next entry didn't just join this category, it caused the category to exist, and when astronomers first measured its size, the reaction inside the research team was something close to panic. Level 2. Mike Brown had been hunting for large Kuiper Belt objects for years before his team found Eris in January 2005. When they processed the images and ran the numbers on its size, the atmosphere at Caltech was reportedly somewhere between alarm and chaos. The object was bigger than Pluto, a lot bigger by the initial measurements. Brown later described the feeling as discovering you had accidentally broken something you couldn't fix. If this thing was out there and it was bigger than Pluto, and Pluto was a planet, then this was a planet too. And if this was a planet, what else was out there? The team nicknamed their discovery Xena before the official naming process began. Its moon got called Gabrielle. When the IAU eventually formalized things, the object became Eris, named for the goddess of discord, and its moon became Dysnomia, daughter of Eris and goddess of lawlessness. Somebody at the IAU was enjoying themselves. Current measurements place Eris at about 2,326 kilometers in diameter compared to Pluto's 2,376 kilometers. They are almost exactly the same size, but Eris is roughly 27% more massive, which means it's considerably denser, probably because its interior is rockier where Pluto holds more ice. The orbit is something else entirely. One full trip around the Sun takes 559 Earth years. The orbital tilt sits at 44 degrees off the solar plane, far steeper than any of the 8 planets. At its farthest point, Eris sits 97 astronomical units from the Sun. Light takes 13 hours to reach it there. For comparison, light reaches Earth in 8 minutes. As Eris swings away from the Sun on its long arc outward, its thin atmosphere of nitrogen and methane freezes and settles onto the surface as a bright reflective frost. When it swings back centuries later, that frost sublimates back into gas. The surface resets itself on a 559-year cycle, which is why it's one of the most reflective objects in the solar system. It essentially gets a brand new face every few centuries, wiping the record clean in a way no other known world does at that scale. Eris forced astronomers to answer a question they had been hoping not to face. The answer they settled on was the demotion of Pluto. Brown later titled his memoir about the whole experience, How I Killed Pluto and Why It Had It Coming. If a world this strange could hide undetected for so long, wait until you hear about one that has physically deformed its own shape just by spinning too fast. Level 3. Gravity is patient. Given enough time and enough mass, it pulls everything into a sphere. Moons, planets, large asteroids, all of them round themselves out eventually. Haumea is what happens when something gets in the way of that process. Haumea completes one full rotation every 3.9 hours. That is fast enough that the centrifugal force at its equator almost exactly cancels out the gravitational pull toward the center. The result is a world shaped like a stretched egg, about 1,960 kilometers, along its longest axis and roughly half that across its shortest. It is the most distorted large body in the solar system. The discovery history is messy. Brown's team found it in 2004, but a Spanish research group made a competing announcement in 2005 after analyzing archived observations. The IAU eventually gave discovery credit to Brown's team, but allowed the Spanish researchers to propose the name. Haumea comes from Hawaiian mythology, goddess of childbirth. Its 2 moons, Hiaka and Namaka, are her daughters. In 2017, a team observed Haumea passing in front of a distant star. The precise timing of how the star's light dimmed and returned revealed something nobody had planned to find: a ring. Haumea has a ring system. A narrow, dense band of material orbiting about 2,253 kilometers above its surface, locked in a 3-to-1 resonance with the rotation below it, meaning ring particles complete exactly 1 orbit for every 3 rotations of Haumea. It is the only known trans-Neptunian object confirmed to have rings. Saturn's rings are broad and icy. This one is compact, dark, and circling an egg-shaped world. The leading theory ties everything together. A large object hit Haumea billions of years ago, accelerated its spin, scattered material into orbit to form the moons and ring, and sent fragments flying outward into the Kuiper Belt. Astronomers have identified what they call the Haumea family, a cluster of Kuiper Belt objects with matching surface compositions, probably all debris from the same ancient collision. That single impact billions of years ago essentially populated an entire region of the solar system with its own leftovers. And we can still trace them by their fingerprints today. The next world is quieter, colder, and in some ways more unsettling precisely because of how little it has been willing to give up. Level 4. The discovery was announced around Easter 2005, and someone at the IAU named the new world after the creator deity of the Rapa Nui people of Easter Island, Makemake, god of fertility and bringer of humanity. The name landed on one of the most barren surfaces we have ever pointed a telescope at. Makemake sits about 45 astronomical units from the Sun on average. Its surface is coated in methane and ethane ices that keep it highly reflective. Surface temperatures hold around -240 degrees Celsius. It is slightly smaller than Haumea, making it the 3rd largest confirmed dwarf planet. And for the first decade after its discovery, it appeared to have no moons at all. That absence was telling. Most large Kuiper Belt objects have at least 1 moon, typically debris from a past collision. No moons suggested a quieter history, a world that hadn't been hit hard enough to scatter anything into orbit. Then Hubble found one in 2016, small, roughly 161 kilometers, now called MK2. The moon itself is not the interesting part, the color is. Makemake is bright, almost white. MK2 is nearly black. That contrast tells a story. MK2 has probably lost its surface ices over time. What remains is a dark, processed layer of organic material called tholins, formed when ices get hit by cosmic radiation over billions of years. Same region of space, same starting conditions, and yet two objects with completely opposite surfaces orbiting each other. It is a before and after sitting in the same orbit, one world showing what the other used to look like before billions of years of radiation stripped it down to its darkest layer. Whether Makemake has any subsurface liquid is genuinely unknown. Whether any geological activity has happened there in the last billion years is unknown. There are no spacecraft currently heading toward it. Every piece of data we have comes from telescopes staring at a small object roughly 7.2 billion kilometers away. It might be completely dead, or it might be doing something quiet beneath that frozen crust. Nobody knows, and there are currently no plans to find out. What Makemake does share with the rest of this list is that it keeps forcing the same question. How much can something this small, this cold, and this far away actually be doing? The next entry answers that question by breaking a rule that physicists thought was essentially unbreakable, but it does so as something the solar system has not yet officially recognized. Level 5. The boundary between what counts and what doesn't is thinner than most people assume. Official classification in planetary science is not always about the object. Sometimes it is about how well we've been able to measure it. And some of the most interesting things out there are sitting just outside that line. Not because they are small or simple, but because the universe put them somewhere inconvenient. And then there is Quaoar, a dwarf planet candidate in the Kuiper Belt, roughly 1,110 kilometers across, orbiting the Sun at about 43 astronomical units. Discovered in 2002 by Chad Trujillo and Mike Brown, and named after the creation deity of the Tongva people, the indigenous inhabitants of the Los Angeles basin. Not officially confirmed, not yet given a seat at the table. And yet it broke one of the most established rules in planetary science. There is a rule called the Roche limit. It describes the boundary around any large body inside of which tidal forces are strong enough to tear orbiting material apart before it can clump together. Rings form inside the Roche limit because the material can't consolidate into moon. Beyond it, particles stick together, build up, and eventually become satellites. That is how the solar system is supposed to work. Quaoar ignored it. In 2023, astronomers confirmed Quaoar had a ring, and not just any ring. Its ring sits at roughly 2.5 times the planet's radius from its center, well outside the Roche limit. By every established model, that material should have clumped together into a small moon within a few thousand years. The ring has no obvious reason to still be there, and yet there it is. The leading explanation involves temperature. Ring particles at Quaoar's distance are cold enough, around negative 220 degrees Celsius, that collisions between them may be more elastic than sticky. Instead of adhering and building mass, they bounce. The ring persists not because something is replenishing it, but because the conditions that would destroy it aren't quite met. Quaoar also has one known moon, Veywaut, whose gravity may be shepherding ring particles back into their lane before they can consolidate. What Quaoar implies is that physical rules are not always universal. The Roche limit math still works, but the assumptions built into it don't hold everywhere. And if that is true for one unconfirmed world at 43 astronomical units, it raises a harder question. How many others are out there operating by rules we haven't accounted for yet? In 2003, astronomers discovered Sedna, roughly 966 kilometers across, dark red, and orbiting the Sun on a path so extreme that its farthest point reaches 937 astronomical units from the Sun. One full orbit takes about 11,400 Earth years. At its most distant, Sedna is nearly 25 times farther from the Sun than Pluto. The problem with Sedna's orbit is that it shouldn't be there. At those distances, the Sun's gravitational hold is weak enough that a passing star should have either pulled Sedna away or bent its path into something completely different. The fact that it is still on this specific trajectory means something put it there and something may still be holding it. Sedna is also not officially a dwarf planet. Its size has never been confirmed precisely enough, and no spacecraft has gone anywhere near it. What it is officially is a distant, detached object, a world so far removed it doesn't fit cleanly into any existing category. Several other extreme Kuiper Belt objects have a similar problem. Their orbital paths are clustered together in ways that statisticians have calculated are unlikely to be coincidental. The probability the clustering is random has been put somewhere between 1 in 100 and 1 in 1,000. In orbital mechanics, that kind of pattern tends to mean something is doing it deliberately. The proposed explanation is a large undiscovered planet, somewhere between 5 and 10 times Earth's mass, sitting between 400 and 800 astronomical units from the Sun. It has been called Planet 9. It has been searched for extensively. It has not been found. The telescope most likely to settle this is the Vera C. Rubin Observatory in Chile, which reached full survey operations in 2025. Researchers expect it to either detect Planet 9 within the next several years or rule out enough of the sky that the hypothesis becomes very hard to keep defending. If Planet 9 exists, it qualifies as a full planet. Its discovery would almost certainly bring dozens of new dwarf planet candidates into view alongside it, objects that have been perturbed into detectable orbits over billions of years by its gravity, sitting out there undetected because nothing we've built so far has been sensitive enough to pick them up. The solar system, as most people picture it, ends around Neptune, roughly 4.5 billion kilometers from the Sun. The solar system, as astronomers currently model it, extends somewhere between 1,000 and 100,000 astronomical units out, and most of that volume has never been surveyed. Every major telescope program over the past 30 years has found more objects in the outer solar system than the one before it. That pattern hasn't changed. Every generation of instruments has pushed the boundary further out, and every time it has, something new has been sitting there waiting to be seen.